Hello all, welcome to the day 77 of the daily case study series for CBSE grade 12. The question goes like this. If A1, B1, C1 and A2, B2, C2 are direction ratios of two lines, say L1 and L2 respectively, then L1 is parallel to L2 if and only if A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2, and L1 is perpendicular to L2 if and only if A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Question 1. Find the coordinates of the foot of the perpendicular drawn from the point A to the line joining B and C. Assume this is the line BC. B is given by 1, 4, 6 and C is given by 5, 4, 4, and there's a point A which is 1, 2, 1, and from here we drop a perpendicular to the line which meets BC at a point say D. Now we have to get the coordinates of the point D. Now let's get the equation of the line joining B and C. X minus x1 upon x2 minus x1 is equal to y minus y1 upon y2 minus y1, which is equal to z minus z1 upon z2 minus z1. So here x1, y1, z1 is taken as the coordinates of B and x2, y2, z2 is taken as the coordinates of C. So x minus 1 upon 5 minus 1 is y minus 4 upon 4 minus 4, which is z minus 6 upon 4 minus 6. Let this be some lambda, and x minus 1 upon 4 is equal to y minus 4 upon 0, which is equal to z minus 6 upon minus 2. From here let's get x, y and z. X minus 1 upon 4 is lambda, so x is equal to 4 lambda plus 1. Y minus 4 upon 0 is lambda, so y is equal to 4. Z minus 6 upon minus 2 is lambda, and z is minus 2 lambda plus 6. So these are the coordinates of the foot of the perpendicular, that is the point D is 4 lambda plus 1 comma 4 comma minus 2 lambda plus 6. Now that we have these coordinates in terms of lambda, we have to get the value for lambda. By the question, AD is perpendicular to BC. A is 1, 2, 1, and we have got D as 4 lambda plus 1, 4 minus 2 lambda plus 6. So the direction ratios of the line AD is 4 lambda plus 1 minus 1, 4 minus 2, minus 2 lambda plus 6 minus 1, which is 4 lambda, 2 minus 2 lambda plus 5. The direction ratios of BC is given by 4, 0, minus 2. Since AD is perpendicular to BC, A1, A2 plus B1, B2 plus C1, C2 is equal to 0. That is 4 lambda times 4 plus 2 times 0 plus minus 2 lambda plus 5 times minus 2 is 0. 16 lambda plus 4 lambda minus 10 is 0. 20 lambda is 10 and lambda is half. Now substituting the value of lambda in the coordinates of D, we get D as 4 times half plus 1, 4, minus 2 times half plus 6. That is D is 3, 4, 5. 3, comma 4, comma 5 are the coordinates for the perpendicular drawn from A to the line BC meeting BC at D. Question number 2. Find the direction ratios of the line which is perpendicular to the lines with direction ratios proportional to 1, comma minus 2, comma minus 2 and 0, comma 2, comma 1. Now we know the fact that a line perpendicular to both lines has drs equal to the cross product of the two vectors. Let's take b1 as 1, comma minus 2, comma minus 2 and b2 is 0, comma 2, comma 1. So we need to get the cross product of this b1 and b2, from which we get the direction ratios of the required line. b1 cross b2 is ijk, that is 1 minus 2 minus 2, 0 to 1, I times minus 2 plus 4 minus j times 1 minus 0 plus k times 2 minus 0, which is 2i minus j plus 2k. So the direction ratios of the required line is 2, comma minus 1, comma 2. Question number 3. What is the relationship between the lines? The lines are given in Cartesian form. Let's take down the lines. L1 is x minus 2 upon 3, which is equal to y plus 1 upon minus 2, which is equal to z minus 2 upon 0. The direction ratios of L1 is given by 3, comma minus 2, comma 0, and let's take down the second line L2, which is x minus 1 upon 1 is equal to y plus 3 by 2 upon 3 by 2, which is equal to z plus 5 upon 2. The direction ratios of L2 is given by 1, comma 3 by 2, comma 2. So we have to figure out the relationship between the lines L1 and L2. That is, we have to find out if the lines are parallel or perpendicular. For the lines to be parallel, A1 upon A2 should be equal to B1 upon B2 should be equal to C1 upon C2. That is, the ratios have to be proportional. Very clearly, here these two are not proportional. 3 upon 1 minus 2 upon 3 by 2 and 0 by 2. So L1 is not parallel to L2. So we will try getting A1 A2 plus B1 B2 plus C1 C2, which is 3 times 1 plus minus 2 times 3 by 2 plus 0 times 2, which is 3 minus 3, that is 0. Since A1 A2 plus B1 B2 plus C1 C2 is equal to 0, L1 is perpendicular to L2. The R part of the third question, if L1 M1 N1 and L2 M2 N2 are direction cosines of L1 and L2 respectively, then what is the condition for L1 parallel to L2? So given the direction cosines, for L1 to become parallel to L2, L1 by L2 must be equal to M1 by M2 must be equal to N1 by N2. That is, L1 is to M1 is to N1 should be equal to L2 is to M2 is to N2. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi. for more smart learning videos. See you all with another case study question tomorrow.